right, welcome everybody. Welcome to IIoT World's Energy Day. I'm your host, Lucian Fogoros. Thank you for joining. Thank you to the speakers. Thank you to the sponsors for this session. I'd like to urge you to share the comments you see. The speakers are live, they're not pre-recorded, and we make a commitment to you that all the questions you post in the Q&A will be answered. With that, I'd like to transfer over to Kevin O'Donovan, the moderator for this session. Kevin, the floor is yours.
Thank you, Lucian. Folks, welcome, and thank you all for joining us here this morning, this afternoon, or wherever in the world you are. Before we kick off with our panel here this morning on Energy Digital Trends 2.0, a couple of quick housekeeping. As Lucian said, we're all live. And in the tool here that you're watching us on, you'll see on the right-hand side, there's a chat function and there's a Q&A. If you want to use the chat function to tell folks where you're dialing in from today, then feel free. That's for general purpose conversation. We are live. We will be taking your questions. So if you have a question, please post the question in the Q&A. We'll be tracking that as we go through. And as relevant questions come in, I'll start throwing some of your questions back to the panel. The session will run for about the next 55 minutes. And we're going to keep it as interactive. Apart from the slide that you see on the screen, there's no other slides. It's going to be a good, interesting and robust discussion. So with that, I will briefly introduce each of the panelists, and then I'll call on each one to give us a quick introduction on themselves and to kick us off. The topic we're going with this morning is the Energy Digital Trends 2.0, unlocking the predictive ecosystem models. Now, digital twins mean many things to many people. We'll be talking about what we mean by that. You know, what are the benefits? What are the opportunities around this? What are the challenges? Because it's like anything, there's a lot of change. There's a lot of things required to get these up and running. So I'm delighted to be joined here on the panel with Balaji Palani. He's Vice President, Product Marketing at InfluxData. And thank you to InfluxData. They are the sponsor of this session. We're also joined by Calvin Hammes, the Director of Software Engineering at A&E Engineering, and Daniel Young, the Senior Manager of Digital Innovation Strategy at Toshiba America. Folks, welcome everybody. So if I may, Balaji, if you want to do a quick introduction and give us your opening thoughts on Energy Trends 2.0.
Thank you, Kevin. Hey, excited to be here, folks. My name is Balaji Palani. As Kevin mentioned, I lead the product marketing at InfluxData. If you're not familiar with InfluxData, we are the makers of InfluxDB. It's a time series database purpose-built to handle time series at scale. I'm super excited to be here. I'm joining, by the way, from East Bay, California, Bay Area, San Ramon specifically. And it's about 7 a.m. in the morning. But I'm here specifically because I'm super excited to be engaging in this conversation with these folks on energy and digital energy. Over the past 5 years, I've worked with many customers as they onboard, as they evaluate our products, going from the legacy technologies that they have. It could be Aviva, it could be Historian, whatever, and getting into the modern way of monitoring and doing the digital twins as they embark on their journey to sustainability and renewable energy and so on. It's just monitoring, management, and all the things that benefits that they get from this observing in real time the digital twins, using digital twins 2.0. Thank you, Kevin.
Thanks, Balaji. And Calvin.
Thanks, Kevin. I've been working with A&E Engineering for a couple of years now. I'm the Director of Software Development. I come much more from the implementation side of the world. So people who have digital twin implementation strategies they want us to implement, they like to call on us to say, hey, how do we do it? How do we begin this journey? And that's when we start, working with companies like InfluxData, other organizations to say, this is the best way for you to implement the strategy. And there's a nice point where we have to interview the stakeholders and figure out how we're going to actually implement any of this. So I'm really excited to be here to talk about not only the whole topic, but there is a piece of the topic that we're not going to get to dive into too much, but I just want to really call it out, and that is making sure that your pipeline for your data is scalable. We're not going to dive into that, but it is such an important piece to think about when you're implementing a digital twin, is how do you scale this thing to a global type of organization?
Oh, great point. Thanks, Calvin. Daniel.
Yes, yeah, good lead in. That is kind of Toshiba's journey for the past few years, is how to scale that out to large. Of course, Toshiba has a very long history, 150 years old this year. We are in generation, delivery, storage use of energy systems. So, as I was mentioning earlier, we have our turbine plant is in Milwaukee, but we also do wind turbines. We do hydroelectric, solar, nuclear, of course, and delivery with transformers and storage systems with our battery storage system, which is in Houston, Texas there. But that's the history of Toshiba, but the future of Toshiba is in energy management systems. And so that's where I come along. I work with our research and design center in Japan, and we are deploying industrial IoT technology into the energy field. And that's part of Toshiba Spinex for Energy, which is our IoT platform for all of our energy solutions, whether it's turbines and asset performance management, all the way up to what we've been doing for the past few years in Japan with virtual power plants, where we're taking distributed energy resources and kind of combining those together as digital twins, and creating a service that allows those smaller energy resources to sell their energy on a Japan's energy market.
Yeah, you make a great point, because a lot of people look at what's happening in the digital twin space today and kind of go, well, that's only for the big guys, the small guys, it's too complicated and whatever. And I'm sure we cover that. Right. So let's start off, and I'll open up this, Balaji, I'll come to you first. Cut a long story short, when we talk about digital twins 2.0, you mentioned the modern way of doing things. What do you mean by that? What is it? What is a digital twin 2.0 in today's world?
No, great question. So I think it's important to understand, how existing or how yesterday's, when you talk about digital twins in today's world, let's talk a little bit about yesterday's technologies, right? So in the existing legacy world, there are all of these energy solutions available, which are generating data using SCADA systems. Again, I worked with one of the companies where they wanted to do real-time monitoring in order to, make sure the assets was running, to do predictive maintenance and so on. But actually, if you look at them, they were trying to extract data manually and trying to get them into cloud solution and into running some advanced analytics solution on that. The whole process for them, according to the customer, took about from days to weeks to really get that data. When you do that, that actually puts you at a disadvantage, because by the time you take action and insights on the data, it's already too old. The machine status is completely different. So that's what I mean by, the older technologies. And when digital 2.0, you're looking at real-time monitoring using industrial IoT sensors. You're using that data into some system which can allow you to do AI and ML. When I say AI, ML, I'm not trying to AI wash. I mean, everybody does that, but actually, I mean truly using an algorithm. There's plenty of algorithms available today to understand how do we predict where you're using your digital 2.0 models. Where do you think the problems are going to be, and be proactive, run some things before you get into it. That's what I mean by digital twin 2.0, at least from my perspective.
And if I may, Calvin, from your side, when people say the modern digital twins 2.0, how do you frame that?
I first want to call out something that Balaji said about the days to weeks scenario. I always like to use the example of, you would not believe how much of this world is run by Excel spreadsheets and manual inputs to do everything. So I think a big part of it is just getting to that 1.0 of getting off of the Excel spreadsheets. Because as soon as we can start digitizing that data and storing it, then we can start making insights into what's actually happening, and then move into that next advanced layer of the analytics, the AI, the ML predictiveness.
And Daniel, from your side?
Yeah, I agree with that completely. Our EdaPro business has been using physics-based digital twins for a long time, but what has changed in the recent years is the advanced use of AI machine learning algorithms to take those physics-based models and kind of take them to the next step, and that's really been enabling the predictive maintenance side of saying, here's what's going to happen in the future, and so now you can plan for service downtime or whatever well ahead of that.
Well, I'm here in Houston this week at CERAWeek, and you honestly cannot walk around here without AI hitting you somewhere. It is AI hype land, and again, a lot of people talking about digital twins. Now, I'm going to go back, and I know, Calvin, you called it out, but I think we can just jump in there, because just the level set around the data. I've seen a lot of people, and a lot of people will say, well, you can create a digital twin, and we created a lovely digital twin, but it was like a one-off. And to your point, it didn't scale. And a number of you mentioned about, well, you need to have the data and data in real time. Now, real time means different things, but at the same time, can we unpack that a little in terms of what's the role of accurate, consistent, and data that keeps coming in regularly as a foundation for any digital twin? Anybody want to take that? Calvin, you mentioned the whole data rat hole, so let's go there.
I think what you said is so important, is just being able to collect that data and accurately store it. That's another key piece, is to be able to look at the data and make sure that you're not getting anomalous data things from a loose connection or a sensor going bad. And if a sensor is going bad, maybe that is something you do want to collect, but you do want to be able to look at data and say, hey, if my connection is loose on my sensor, I need to be able to notice that that is a bad piece of data. And maybe it indicates that, hey, I need to change something, or it might be something you just want to throw away. And that's where I think, the data collection is very important, is to be able to look at that and determine, am I looking at something that's valuable, or is it just something that's off the wall?
I can go on to that. So I think what Kelvin's talking about, just collecting that data, if you're just collecting data from either laptops or machines, a lot of technology is available. You have to understand that these are large equipment that's out there, solar farms, windmills, and so on. That's in a remote location. And in those cases, chances are the connectivity is not right. You have to have data collection. You have to collect that data in real time, maybe store at your edge location. I'm going to introduce some things like edge, store it locally. And then when the connectivity is established, some of them have connectivity. When it's established, send it over into a central place for you to extract the insights and monitor that data. All of this require careful planning, multiple redundancies. Also, if you're doing predictive maintenance, then these data will be into the final step or that step where you're running those models. So you're talking about an entire data ecosystem pipeline and thinking about them, collecting that, and then introducing into the central hub where your data teams are going to act on it. All of this takes planning, and then trying to extract that data for real-time monitoring and real-time predictive maintenance.
I want to add just one more thing to that, and you said a very key word in that, and that is planning. Any successful data twin or digital twin system requires planning. How you're going to set up, getting the right people involved, determining what digital twin means to each one of those people. because if you say digital twin means X and I say digital twin means Y, when we implement a system and it shows up X, no one's going to be happy, or I'm going to be happy. You're not going to be happy. And then you may say this is a failure of an implementation. So really planning it out and then starting to think again about that scale at the beginning and like, okay, we're going to implement it at one place. What happens when we want to introduce 500, 5,000? Because if we aren't thinking about that at least a little bit up front, the chance of success is very low.
No, that's a very valid point. You know, I get involved with various companies around some of their strategies and whatever, and I'm a big fan of Post-it notes. And you have a team meeting, and either it's online or you have it in person, and they go digital twin. I go, great. Can everybody write down right now what you mean by a digital twin, and then we'll stick them on the wall. Step one, and they go, okay, we know what a digital. I said, I'm sure you do. Just write it down. And you put it on the wall, and you find that some guy's looking for a photorealistic, God knows what, and the other guy's looking for a predictive maintenance. And to your point, they're often the wrong foot. Now, you also mentioned, like, don't build a silo. It's all about the scaling. Again, I'll kind of jump into a rat hole here in terms of when you say the stakeholders from the project, and Daniel, a lot of the work that you do, you'll often see people say, oh, we want to do a digital twin, and you get all the people who are into digital twins, and they're all the guys in the room. What's the right stake? How do you figure out who the proper people should be in the room?
Well, and as far as predictive maintenance and those things go, your customers probably don't care if it's a digital twin or not. They want the solutions. And I was at a conference last year, and one of our customers said, I appreciate that Toshiba's solutions don't tell me when our equipment is shut down. We already know that. We have boots on the ground. We are looking for, we want the solution that tells me, how do I prevent this from happening 6 months, 1 year from now? And that's part of the digital twin is providing those capabilities so that you can look forward ahead into the future and really provide that predictive part. The operators, they don't need to know when the turbine is shut down immediately. They're there. They see that. They want to prevent that from happening in the future. And I think that's what the digital twin should be about in those type of situations.
So just one thing, folks, I see a lot of folks in the chat, so please keep telling us where you're dialing in or where you're joining us from today. But I would ask, I've seen a couple of questions in the chat. Please post the questions in the Q&A. There's 40 or 50 people have already posted in the chat. But if you have a question, do stick it in the Q&A, and we'll take them from there. Now, I suppose Balaji, if I may, you mentioned it as well. There's many different use cases when people are looking at predictive maintenance and whatever. But I suppose there's also things around energy efficiency, sustainability goals. Sustainability still means money. So I'm guessing there's a whole use case or a business case around that as well.
Yeah, totally. So here I'm going to venture off a little bit into some of the customers that have come to my mind. I think if you look at energy sustainability, and I think one of the customers I've worked with, I don't know whether I can name them, but okay, Scottish Power Energy Networks, right? So they are a customer, and they have publicly posted, if you want to check it out. They were using legacy Aviva Historian to monitor their asset, do their asset monitoring, and they were spending close to 1.4, greater than a million, not dollars but pounds, in order to really manage those networks or manage those energy utilities that they have. And they actually ran a public program wherein they tried to use, again, I'm pitching in InfluxDB here, but you can pitch in any time series. But let's say that you take InfluxDB, you use InfluxDB with a combination of Grafana, with a combination of how to extract data from using Telegraph and so on. With that, they were able to drop their costs from one point put down to 200, about 7x. And this is not just related to them. I've seen with other customers as well. So again, the point I'm trying to make it is when you talk about energy sustainability, right? When you want to invest in new renewable energies and so on, you're looking for, hey, how do I fund those, innovation? And when you have cost draining technologies, legacy technologies that aren't open, you may want to transfer, you may want to look into other technologies which could open up those investments for you to go down the line, compete with other competitors and try to invest in renewable sources and show the innovation in those energy sustainability use cases. I don't know whether that makes sense, but I think I thought I wanted to provide an example how that happened.
Well, I've seen something in the comments as well. Somebody had said, well, are digital twins just for predictive maintenance? And I suppose I come to all of you. My own thing is that you can have a digital twin from what you're going to build with your CAD/CAM model. You can have your digital twin of what you're building with reality capture. You can have your digital twin of a running system with real-time IoT data, all the way up to an autonomous digital twin that'll whatever lights out. So again, whatever. But if Calvin, Daniel, in terms of what you're seeing in terms of people, the different use cases, sustainability angle, energy efficiency, productivity, what are you seeing out there in the real world?
Yeah, sorry if I'm focusing on predictive maintenance. It's just I'm trying to give real world.
It's a valid use case.
Right? Yeah. But so and I try to think of specific ones to talk about because there's all kinds of use cases. And if as a member of Toshiba's a member of the Digital Twin Consortium, and that that consortium has just hundreds and hundreds of use cases. So I have to focus on one to that's just me personally. But now the other one I would talk about is our virtual power plant. And that's a concept that, that's globally and everybody has their definition of what a virtual power plant is. But really what we see it as is okay, you can have a solar farm and you can build digital twin of that solar farm. And you might use that, the solar farm operator might use that, but what about other companies, other resources? What if they could use a digital twin of that solar farm? What could they do with it? And that gets into what I consider a system of systems level thinking, where if you take aggregate digital twins and take all that data, put it together, what could you do with it? Well, we believe that you could do a lot more than those individual digital twins could do by themselves. And so the virtual power plant is kind of is that idea of what could you do with aggregate digital twins from across the board, say a lot of different renewable energy resource providers. And that's part of our process in Japan, where we're aggregating those resources and we can sell their energy on an energy trading market and give them more benefit than they could by themselves. And actually, we then running that pilot project and the results of that, where we showed 3 times profit for those distributed energy resources than they could do by themselves. So that's just another example of how digital twins are immensely useful.
Maybe I want to add one more thing, because you mentioned energy trading that just triggered something in me as well. I think I don't remember the customer name, but they also do the energy grid balancing. So they are maintainers of the distribution grid, especially when the electricity has to be distributed. And they use BESS or battery energy storage solutions to store the energy when there's excessive supply. And then when the demand actually goes up, they're able to release that energy and then kind of operate in a, they're not into energy trading, but they actually kind of balance the grid so that make sure the supply and demand and maintained. And that's a great use case. And that requires, when you actually do those kind of things, and I clearly remember this customer actually took all of the demand and supply, they actually run through multiple algorithms to really figure out when they have to release that excess energy from the battery solutions, or when they have to store it into the battery solution. Really great use case. But just wanted to point that out because you mentioned that trading, so immediately it just struck me.
Yeah.
And
it's the digital twin that allows that, right? There's all these new business opportunities. Yeah, sorry, go ahead, Calvin.
And Daniel, you mentioned the Digital Twin Consortium. For folks that may not be familiar with that, Digital Twin Consortium, go check out their website. One thing there, when we talk about digital twins, again, you typically come back to, well, what capabilities do you want? Is it around predictive maintenance? Is it around design? Is it around 3D models, whatever? So the Digital Twin Consortium have what they call the periodic table of capabilities. So think the periodic table, 56 or 70 different capabilities. And I think it's a great way of people sitting down and going, well, I want to have a digital twin. Well, what do you want it to do? And you can start ticking off the boxes, because a lot of the questions are, well, is it just predictive maintenance? Well, we're focusing on that here, because otherwise we could have had a webinar for the next 4 weeks talking about digital twins, because it's such a wide topic. Now, before we get on to the challenges, if it's so easy, how come everyone's not doing this already? There's one question here from Dorina and Balaji. I'll come to you. It's typical question I would see as well. Well, what is the delayed time between the twin and the real equipment? I suppose it's back to, what do you mean by real time?
Yeah, no, great question. In my view, again, there are a lot of real world challenges that I think we spoke about, how it's difficult to get the data from your actually physical systems onto a digital version of your physical systems, right? So, but in real time, I've seen things happen in seconds. That's kind of what the real time I've seen, really, really fast, where, hey, everything is super connected with good connectivity. In those cases, all of your the data that the sensors generate are able to get captured within at the edge, also are available into the cloud within seconds. I've seen that fast. I've also seen, as I mentioned, delays, and when you have connectivity issues, those things could come in as sometimes late arrivals. Sometimes it could take a few hours delayed, sometimes to a day even. But those are some of the things. But in real time, digital twins, I would say, especially if you have good technology out there, you can get data back in seconds and insights in seconds. And depending on what you do, either you're doing the grid balancing or not, or if you want to do just predictive maintenance, you have some time to run through those algorithms and then come back and say, hey, you're doing some predictive maintenance there. But that's kind of what I would give from a perspective of what I've seen in the real world.
Daniel, Calvin, any comments on that?
I think the great answer for this is, it really depends on how fast your network is going to be your key limiter.
I wanted to avoid that answer, but yeah.
to answer this. But Balaji brought up such a great point about having an edge device of some sort, so that if you do need absolute real-time decision making, you have that edge device, and then you can send that data out to a cloud that may be running AI models, that may be doing much more advanced analytics, and let it do the processing there, and then send those answers back. But that edge device is really key, especially in some of the energy sectors where I know those connections are not quite as nice as, what we're experiencing right here with great internet connections inside of our homes or offices.
Yeah, and in terms of scale, you need to, I think you need a phased approach, because what real time might not be the same thing between different customers. You might not need sub-millisecond accuracy. It might be good enough to have 1 second or 15 minutes. It really depends, and you don't want to spend a lot of resources developing a real-time system when you absolutely don't need it, because that really runs the costs up. But if in a lot of legacy situations too, you can just simply take a phased approach, deal with what you have, and then as you need higher fidelity you can, incrementally increase your edge equipment. But absolutely, edge is key. We take kind of a three-tiered approach. You have edge, platform, enterprise, and that enables you to scale as the customer needs it.
Mm. I suppose what I've seen out in the energy space, and to what you've mentioned, again, it comes back to what are you trying to do? So if you are looking to have a digital twin to tell you in real time what's going on, then you probably do need millisecond response time. If you're running a transmission grid, it's sub-millisecond. Or if you want to know something's breaking. But if I want to do something around predictive maintenance, maybe the data comes in once every 15 minutes, once every day. And then I run the AI, the machine learning algorithms, and that'll tell me, hey, look, the way this thing is degrading, you need to fix this in the next 6 months, or it's going to break in 6 months' time. So again, it's back to the capability. Now, there's two questions that have come in, and I'm going to link them together. Daniel is asking, when you're building digital twins, there's all sorts of data inputs, and you've mentioned, I think Balaji and other, Calvin, you mentioned spreadsheets and whatever, right? Someone's typing them in. Not great for real time, in fairness. But any tips or tricks? Because again, big topic with AI right now is, we need to get all the data and we need to train the model. If the data is not good, well, guess what? You're not going to train a very good AI. So how do you, if you can give any examples or whatever from projects any of you have worked on, in terms of how do you ensure data quality?
I mean, I can start. I think you mentioned, hey, you wanted to run data through your AI models and so on. Folks may not realize this, or maybe you do, but typically the AI models that you run, you can't just send it like 1,000 samples or 10,000 samples. You really need a lot of data in order for that AI model to understand and then try to learn and then predict based on your data models and the data being generated. Why I'm saying that is that means that you need data at high granularity. Already there's sensors which can produce in terms of 1,000 hertz, which means that 1,000 cycles a second. So they are sources, sensors that can produce that data. But do you have technologies in place that can extract or ingest that data as they're producing? And usually these are time series data, right? So time series means they change over time, maybe a few things. But also the data when you're extracting from a particular sensor, you have to understand where it's being produced from. All of these form tags, or what we call as tags. So they generally give you the context about those tags. So these are dense data that you need technology to ingest and store, and then be able to extract analytics from and insights from. And we have worked with many customers who can actually need these requirements. And you use either again, these are SCADA systems, so you might use different protocols, OPC Array or others, to extract those data and then send them into your cloud and so on. I think going back to what you were saying earlier, it's super important to capture that granularity and denseness of that data in order for you to run through the AI models. At least from my perspective, I've seen that.
Yeah. But you also need to have the anomalies in order to train those algorithms. So if let's say a bearing is failing, a bearing might not fail for 2 or 3 years. So collecting data over a period of time might not give you all the information you need. So it's important to also have either the ability to generate anomalies so that you can build training models, or to have the subject matter expertise and maybe that data already available. And so, that's kind of a twofold approach. Is for Toshiba, we have a very long history of building this type of machinery. So we do have that anomaly data collection already available. But when we work with our customers, we also realize that they have subject matter experts. And it's very important to work closely with those operators, because they know their equipment as well. And so getting that human impact is very important, and understanding how they use their equipment, the history of that particular piece or how their plant works. That can give you a lot of insight into how to analyze their system and make more accurate AI models.
Now, folks, the questions are flying in. We are not going to get to be able to answer all of them, but I think, as Lucian mentioned, we will follow up offline with various questions. But just want to throw out here, and excuse my pronunciation here, Vishwanch has come up with a question. And Balaji, for you, do you provide any, I don't know, predefined templates or recipes or data model? Does everyone have to start from scratch, or is there, here's something we did somewhere else, and for this particular use case in this industry, here's a template, for want of a better word?
Yeah, no, that's a great question. There are plenty of, the product itself doesn't provide out-of-the-box templates. That's not, if that's what the question is. But we actually work with Calvin, A&E Engineering. We actually work with partners like that. They're the first step, right? So typically when you have a digital twin project, you actually approach and these implementers, and they have templates. They can do assessments for you, and then maybe Calvin can talk more about that. And then they can also make sure to tell you, hey, this is what it's going to cost you. These are the technologies. These are, based on your requirements. Hey, I need real time. I need predictive maintenance, or I'm doing grid balancing or things like that. So based on the use case, they will give you, hey, we have done this at this customer before. These are the things that you should. This is the technology stack that you'd be using, and they would really do that. Templates. This, just to assure you, this has been done before. Others are doing it. It's constantly happening. It's not something you have to start from scratch. Your mileage may vary, but depending on your use case. But actually, there are templates available that can help you in the process. Calvin, you want to add something more to that?
No, you spoke to it very well. We like to approach it as like a consultative approach of like, we are going to come in to talk to, again, you're going to hear me say this word over and over, your stakeholders, and interview all the people who will be involved in this project and get what's important to you. And from there, we can start deciding, okay, like you said, there's a really good chance we have done something similar to what you're trying to accomplish, or exactly what you're trying to accomplish before. So our dev lead time to get this implemented is usually much faster because, hey, we've done it before. We know what you're trying to accomplish. And because of that, we'll be actually able to give you some insight and say, hey, did you think about this? Have you thought about that? Because you may not think of something as a stakeholder and say, oh, why didn't I think about that? But that's kind of a good idea. Or you could listen to us and say, oh, yeah, that's not really important to us right now. And we'll just say, yeah, that's cool. We'll do exactly what you're still needing.
Now, there's a question here as well from Peter, and Daniel, maybe you want to have a look at this one. When you're doing predictive maintenance in a factory or energy facility, you will have a lot of different OEM equipment, and all those systems typically come with an OEM system. So you have a system of systems. How do you approach? I know, is consolidation the right word, but how do you pull it all together?
So that's and I'm a big believer in standardization. I've been involved in Toshiba standards work for, I guess, over a decade now. But yeah, it's communicating the need for open standards, whether that's physical protocols or semantic, syntactic, interoperability. All of that is very key. I think in recent years, we've seen a lot of consolidation around, a couple of very well-known good standards, like either it's MQTT or DDS or any of those type. That's very important. Otherwise, you have to build your edge equipment to be able to support multiple protocols. So I think the more standardization we get, the better, because that reduces the number of different protocol transfer that you have to build out.
One
but
thing
we try to support. We just try to, right now the reality is you just have to support as many as there are. But I'm glad to work for a company like Toshiba that really supports open standards work, because I think most of the big companies realize that that's really the best approach.
Calvin?
Another great thing is the past few years, there's been such a great influx on creating what's called, we call a data ops platform. And basically it's a normalization tool, and they usually connect to almost every type of device, allows you to manipulate that data and then send it out to another platform if needed. And a lot of them are smart enough now that you can just run a lot of your analytics on the edge where these data ops are installed. So data ops is going to be your biggest friend when you get into especially a bunch of different types of machinery, protocols, all the different variables that you could do. Send it into one place, normalize it, and then send it out to whatever your enterprise system is.
So folks, we have about 15, 16 minutes left. And obviously we want to get final takeaway comments as well. But there's 3 topics that we wanted to touch. One just came in on a question and there's 2 others. So we can take them in any order. Calvin, you mentioned one topic is, what's the role of edge in all of this? With more and more compute going out to the edge, is data not going to be coming back to the central cloud in the sky or the central data center? Is it going to stay out? Second one is the elephant in the room in terms of, well, what role do you think AI will play in this? And, the new AI, Gen AI, large language models, foundational model, blah. And the third one is, I'm assuming cybersecurity hasn't gone away. So there's 3 topics we want to cover in the next 15 minutes. So if we want to start, let's say on edge, what's happening with edge these days? I'm seeing more and more compute power being deployed at the edge. Anybody?
No, I think what you said is super important, and the biggest factor of that is how much money do you want to spend on your cloud bill with your with your storage, your ingest, your compute in the cloud. If that's not a big issue, send it all. Go crazy, send everything you can to the cloud, and just don't cry when you get your bill at the end of the month. Otherwise, you're going to want an edge device out there, at least taking a look and see, what do I need from all of this data, and sending the piece they want. And it might be something as simple as putting a local time series DB on your edge compute as well. And if that gets transferred to your cloud at a later date, then you're never losing anything. It just, your option is going to be, hey, we're going to empty this local DB into our cloud at some point, instead of a constant stream.
Yeah, that's a great point. Actually, I also want to say that typically at the edge, where depending on where it is, right, that's where your field technicians, your OT engineers are looking at things. So they need the high fidelity of that data. But in the cloud, if you were just doing trending or seasonality and things like that, you may not require that dense data that you have the edge currently. So you may want to, there are a lot of techniques. One technique would be downsampling. Downsampling simply means that instead of the denseness, you're just reducing, sort of storing every second, you're reducing it to every day or every hour, perhaps, or things like that. So the data is not that dense. And then you shift that data over to the cloud. So there are a lot of techniques available to really do that. But those are some of the things that you could often opt in for.
And I would just add to that, scalable architecture and modular architecture services. We see a lot of hybrid approach. Some operators are still not comfortable with using the cloud yet. So as they want stuff at the edge. So, okay, we build it at the edge, but because the architecture is composable using microservices, we can translate that to a cloud service as the customer feels comfortable with it, or as they want to. So I think that's very important. Edge, the compute power is always going to be changing, and so the edge is going to get more powerful, or the cloud is going to get more powerful for one application or another. So you really need a composable approach.
No, they're very valid. And certainly what I'm seeing is, that there's just more and more compute. We're seeing NVIDIA, Qualcomm, you name it, right? There's more and more compute power being put out there. But it's back to Calvin, you mentioned, well, how much money do you want to spend? I came across a company recently and they were talking about digital waste. So I assumed, e-waste, old things. I said, no. How much money are you wasting storing data you don't need in the cloud? Or duplicate copies, or whatever, right? So it's a whole different thing, but that is a thing. Now, I know there's a session coming up later today, I think in 2 hours, on cybersecurity. But I suppose we could spend all day talking about this. But if I may, Balaji, cybersecurity, I'm assuming it hasn't gone away.
Of course not. In fact, it's getting worse because we are talking about sensors. We are talking about the extracting the data, which is open formats. So data is available in open formats. When I say open formats, anybody who knows Python or who knows how to manipulate the data can tap into that and extract that. But I'm not trying to say that there aren't ways to really close out those systems. So at every step, when you're collecting the data, when you're extracting the data and putting into a local store, like Calvin mentioned, there are opportunities where you can do. I'm going to use some technological terms here. You can encrypt that data. You can encrypt on disk. You can encrypt in the transition when the data is being transported, so that nobody can tap into and read all of those data through a port or through another ways. And when you also go from that into cloud, there are aspects that allow you to do that as well. And you can also there are plenty of things available. Like you can set up who has access to the data. Access in terms of which person. Is it because of role, or it's because of particular attribute that is available in the role. Maybe they logged in as a particular persona. Based on the attribute, they can access the data or not. There are plenty of techniques available that people can follow. And even though it is open data format, there are ways to close and to make sure the data is secure, all the while you're trying to do the transport and into AI models and so on.
Right. There's a question here from Seth, and it kind of ties in, I think, with let's say where AI is headed. And I'm here at CERAWeek. I've been at various events in the past 6-9 months. The amount of startups that are coming in with new AI models, foundational models, large language models, I honestly believe that the barrier to entry for some startups let's say solutions. It doesn't always have to be big guys. There's plenty of space. So Seth was asking, is there an opportunity here for the smaller guys to come in with it? I think it depends on the use case and. But related to that, because again, what I'm seeing here at CERAWeek is any new startup, they're talking about AI, and again, of what kind. But where from the experience you folks have, where do you see AI having immediate impact, and where are we headed in the next 12 or 18 months? Daniel?
Well, I mean, immediate impact is, the machine learning models. I mean, they're already in deployment in a lot of our solutions. So we're just seeing that augment the abilities and really moving our services. Talk about asset performance management. It's really enabling the predictive maintenance ability to predict, okay, here's what's going to fail in the future. Here's what it's costing you to not fix it, and so the customer can make a determination. Okay, we're gonna schedule a maintenance period to go fix this problem, but we know that we don't have to fix it now because the AI tools are telling us out in the future what's going to happen. As far as like large language models, all that, I mean, I agree, it's still kind of the wild west, especially if you operate in Texas, right? And it will be interesting to see. I think, we're seeing a lot of LLM usage to help for support, for training, operator training. That's hugely important, very effective. And we're also seeing it as far as reducing development time, building out, like unit tests for in software development, doing some of the user interface, things like that. Just huge productivity gains for software developers. And I just think the use cases are going to keep coming.
Yeah, agreed. Calvin?
I think one use case that's kind of underutilized right now is we are going to have a tradesperson retirement cliff in the next 5 to 10 years, and using these LLMs and some of the more advanced reasoning models of them is going to help fill some of those gaps of, the guy who's been working on the machine for 30 years and he knows this machine inside and out and no one else does. Well, how do you replace someone like that? One option is to augment what he does with an advanced reasoning LLM and help him train that AI so that the next person using it has at least some of that experience.
That's a very good point with the co-pilots and right. There's a lot of the stuff coming there.
So is that a digital twin?
It kind of is, isn't it?
Yeah.
Well, no, this is a complete rat hole, but I've seen some work in Europe where it's like, well, they take my expertise, I create my co-pilot based on whoever's expertise. If I leave the company, does my digital twin go with me? Do I get two salaries if the guy is doing a second job, right? I think it's saying, but sorry, we're off on a tangent. Balaji, AI, from your side, where do you see? And again, as we've said already, AI has been around for years. Machine learning is not new. It's getting better and more sophisticated and whatever. I think it's as Calvin said, it's the large language models. It's the inference. It's the distillation of blah blah blah. So, but from InfluxData point of view, where do you see this headed?
Yeah, from InfluxData point of view, and then when we work with customers, again, there are things that you could do with the LLM, Gen AI stuff, and I love experts to speak to that. Calvin, maybe you're an expert, but I think I'm going to focus on the AI, or ML, which you can practically apply to the models, the algorithms. Even you don't need complex models. At least what I've seen work with customers is that even little things, statistical models, which doesn't require a big AI engine to, there are a lot of things like that. Before AI came along, we used to have statistical models that will tell you that can predict based on, there are a lot of models, ARIMA and things like that, that can allow you to predict what the future values would be. And based on that future value, you can say, hey, okay, based on the future value, is this going to be anomalous or not? There are plenty of things available. And we believe that, InfluxData, we've helped customers to unlock those kind of models. Even step by step, you start with smaller advanced analytics. And then if you want to get into the AI, where you're running Snowflake or Databricks and you want to run an AI model, there are plenty of reference architectures available. You just have to extract the data available. And if you're using InfluxDB, we have technologies called that we store it in open format like Parquet, and we also allow you to have Iceberg. There's Iceberg again. All of these are open technologies out there, but using Iceberg, you can tap into the data without making copies. The other approach would be, hey, I want to copy it into an AI solution, but you don't need to. Hey, all of this data is available. Just allow data access into that format, and you can run through some Python models or whatever, what have you. So that's the InfluxData position.
Alrighty, we're up on 54 minutes, so the time has flown by. So folks, we're not going to get to any more of the questions, but we will be following up offline. I've seen Daniel answering some as well online here. I'm going to quickly go around and ask each one of you for a final closing statement. If there was one thing you want people to take away from our chat here this morning, what would it be? Daniel, if I may, I'll start with you.
Sure. I think if you're looking to, deploy digital twins in your solutions, you should. Best approach is start with pilot projects. Start with something realistic, and something that you think can scale. But I would also offer that don't start with a small ROI. Think big. Don't say, oh, 4 or 5% improvement is enough. No, go for 10 to 20. Use your stretch goals, because if you've not done this before, I think you'll be very surprised at how much productivity gain you'll actually get.
Thanks, Daniel. Calvin?
I'm going to mirror what Daniel said, and the quote I'm going to use is, you don't have to start huge, you just need to start. And follow the land and expand model if you need to. Just start implementing what you need to implement to get it going, because you don't start seeing ROI if you never, cross the start line.
Very, very, very valid point. Balaji?
Yeah, I would like to add to all of the points that the gentleman made, especially in terms of real-time data collection. Think about how you're going to extract the data, plan your process, see what's important to you. I think Daniel mentioned ROI of 10, 20%. Think big. I think I've seen folks get close to 40, 50%. They have, like I mentioned in the example, they've seen their cost go down by 5, 10x. So think of all of these things. Think how this would leapfrog or this would enable you to leapfrog your competition, because guess what? The competition is trying to do the same thing. So you got to get started somewhere. We always have this decision paralysis where, hey, I need to do this perfectly. Yes, but like Calvin pointed out, it doesn't have to be complex. Take one pilot project, start to, or maybe Daniel pointed out, start to do that in one thing, and then you can go from there. Start small and then try to expand from that.
Yeah, but start.
Yes.
I think we've been talking about digital transformation for years. I heard a term at CES. It's not digital coexistence. You just have to be digital. That's the only name of the game in town these days. So you got to start. Folks, we're coming up to the close. Again, thank you so much for our panelists. Thank you to InfluxData for sponsoring this session. Folks, you can reach out to any of us here. You'll find everybody on LinkedIn if you want to follow up with any questions, comments, whatever. We will be following up with through IIoT World with some more answers to the questions. That's one of the things we do. But Daniel, Calvin, Balaji, thank you so much, gentlemen. And we'll see you somewhere in the real world one day soon.
Thank you. Thank you, Kevin. Thanks, everyone.
Take care.